and welcome back to SuperSTEM. So today's video is going to be a continuation of the previous video where we were discussing factors that affect whether an object will float or sink. So in the last video, we talked about density and how more dense objects such as rocks or pieces of metal are going to sink, whereas less dense objects such as sponge or cork is going to float because the particles that make up that sponge or cork are further apart than the particles that make up water, and so they want to sit on top. But today we're going to be talking about another thing that affects floating, and that is surface area. So what is surface area? Perhaps I can give kind of a demonstration. So you know what a surface is. We would refer to this top of the box as a surface, and the amount of space that it takes up is what we call the surface area. So the total surface area of this box would be, if you measured the area of this side, this side, this side, this side, and these sides, and then added them up, that would be the total surface area of the box. And now for this penny, the surface area would be a lot smaller because you see the surface is way smaller. So what does surface area have to do with floating? Well, if we take a look at this penny, it's very small, it has a low surface area, and although it's very light, if you drop it in to water, it'll sink. And that is because it is very dense. Same thing goes for maybe something with a slightly bigger surface area, such as a quarter. That'll also sink as well. But if it has a great enough surface area and proportional to its weight and or density, then it might have a chance of floating. You know, a ship or a boat is way heavier than a penny, and it's made of metal, just like a penny. So why doesn't that sink just like a penny? Well, it's because of surface area. So we're going to take a look. What exactly causes surface area to make things float? Now, as you can see, the greater the surface area, the better something can float. Or perhaps you can't exactly see that, but this ship here is way heavier than this little boat, and yet they both float. Why? Because the ship has such a greater surface area. If this little boat here weighed about the same as the ship, but only had this much surface area, it would probably sink. But because the ship is so big, and it's also hollow, so although it's made of metal, it's not solid metal. So there's air in there and a surface area, and all of that combined allows for it to float. But I already drew some arrows. But you have to consider that the water is made up of a bunch of little particles, and those particles collide and push against things. And in the case of the boat, the particles are pushing against the boat, pushing up on that surface. And when there is a larger surface and more space to push up on, the better the water is able to support the object. Now you could also say the water is pushing up on these too, this boat. So I have a little illustration here of just a flat object floating on the water. And I guess one thing significant to note is that there isn't any water on top of it. The water isn't able to get over the object to push it down. So all of the particles that are in contact with the object are pushing up pretty much because they're only in contact with the bottom of the object. But if we were to, say, create a hole, then, well, the water would want to come up through there, and then it would be pushing down, and that would cause the whole object to sink, probably. You've probably heard the expression a hole in a boat, or maybe even seen a boat with a hole in it. But when there's a hole in a boat, it's probably going to sink because there's water pushing down on it there. So what we're going to be doing today is playing a bit with surface area and seeing if we can engineer our own boats to hold as much weight as possible. I'm going to be using pennies as my weight because they're pretty accessible and I have a lot of them, but if you have little rocks or something else, that's perfectly fine too. But anyway, if you take either a rock or a penny, they're both pretty dense and they're probably almost definitely going to sink if you try to put them in the water. However, if we try to increase the surface area by a lot, by putting it in a boat or something of that sort, then it just might float. So I'm going to be using an aluminum foil, and I recommend that you use it too, to create my own little boat. Now you can make your boat as big as you want, but I am going to use just like about this much. Don't want to use too much, but you need to use enough that you can make a boat that's large enough to hold the pennies. And for this activity, you will also need a container that can hold water, preferably a larger one, so that you can make a larger boat, as well as the pennies or other weight, as I mentioned earlier. Now, there's a lot of ways that you can go about making a boat. I am just going to be a little messy with mine because it doesn't really matter too much. Just as long as it's enclosed in the water, there aren't any holes for the water to get through. So I'm going to just sort of crunch in the sides to create little walls to make sure that the water can't get in. The nice thing about aluminum foil is that it holds its shape, so you can kind of sculpt it like clay, really. And I'm going to make sure there aren't any holes, and we seem to be good. So now I'm going to put it in the water. An aluminum foil being very light and not too dense, and having a large surface area in ratio to its weight, we would expect for that to float. And here it is. I'm going to just make mine a little bit smaller because I want to make sure that it doesn't get caught on the sides of the container so that it doesn't sink because it has a container holding it up. Okay, so there we go. There's our boat. Now I am going to load in as many pennies as I can, and we'll see how many it can hold. 1, 2, 3, 4. And notice that the boat isn't sinking, even though the pennies on their own sank, because they're in this little boat here. They're staying afloat because of the surface area. There's more space for the water to push up on them. So I'm going to keep adding pennies. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I hope this sinks eventually. 37, 38, 39, 40, 1, 2, 3, 4, 45, 46, 47, 48, 49, 50. It seems to still be floating. Upwards of 50 pennies, and it's still floating. I'm just adding some heavier coins now to see if that'll make it sink. Up there we go. So it sank because there were enough coins to weigh down one of the ends so the water could flow in and push the object down. And so that's pretty amazing that just 1 penny on its own can't float. But if you just increase the surface area by a bit, you can suddenly have 50, 60 pennies floating at once. Now, if you had a smaller amount of surface area, we would expect for the boat to not float for as long, or it wouldn't be able to hold as much weight because there's less space for the water particles to push up on. So I'm going to quickly fashion a little boat. Using I'm going to pull this one in so that it's smaller. Making a very small boat. Although the walls are quite high, which prevents the water from getting in. So that might actually help it a bit with its floating. But anyway, here we go. Check for holes. It looks like we're good. We'll put that in the water. And see, that floats just like the larger one. Now let's see how many pennies this one can hold. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 4. Oh, and there we go. Almost. There we go. So this is what happened with the larger one. There were enough pennies, enough weight to push down the boat. And so the water was able to flow over the sides and ultimately submerge the boat. Although one thing to note is that you can probably make the boat float for longer if you make sure to distribute the coins evenly. Like if you stacked all of the coins in one corner of the boat, you would put all of the weight in that one spot, and that would probably cause that corner of the boat to tip down so that water can flow over and then push it down. But if you stack them kind of evenly distributed, like so, there isn't any particularly heavier weight in any one corner of the boat. They're all kind of evenly weighed down. It's less likely that it's going to tip and get water flowing in and pushing it down. So as you can see with the smaller boat, we were only able to hold like 22 pennies, but with the larger boat, we were able to hold over 50. And that's because of the difference in surface area, as I said before. So that's pretty much all for today. I hope that you had fun with that activity, exploring how surface area can affect how well some things float. And I hope to see you next time in the next video. So thank you so much for joining me today, and I hope that you have a great day.